Good morning, everyone. How are you guys doing today? Good. See how gloomy that day is? I hate gloomy days. Let me start with reminding you about the homework. Like I said, it doesn't matter whether I assign them or not. After we finish every section, it's supposed to do the homework and completing quizzes. Okay? So if you don't see them in your weekly list, it doesn't matter. You can go to my math lab and then do the homework from there. But if you don't see anything, go to Brightspace and under homework tab, you'll see all those homework sections are there. All you have to do is click and they will take you to the My MATLAB page. Okay. Once you're done with homework, then you go to the quiz tab and then click on the quiz on the section you just finished the homework on. It will take you to the quiz. So it doesn't matter whether I assign them or not. Okay. Make sure you complete your homework because it's your responsibility and you already know how important that is, right? And I believe I posted a calculator on Brightspace, but I didn't go over that. So let me show you how to use that calculator. You'll see something like this on Brightspace and it has name grading calculator, something like that. So in order to use that, you need everything for this class. So exam 1, 2, 3, you can find them on Brightspace because we took them. For exam 4, 5, 6, just guess some number. And for homework and quiz, you can see them on your Brightspace or My MATLAB. So let me actually show you how to find on My MATLAB. And with this calculator, you can keep a track of your improvement, how much you need to improve in which section in order to pass this class or to get your desired grade. I believe you can see all your overall score on gradebook on Brightspace. If you don't see them, you can get them from My MATLAB, and for some reason My MATLAB doesn't work yet. So I have to go to tab here. So to get your score from My MATLAB, you go to your gradebook. You'll see only your information. For my case, I see everyone's information. So let me pull out Philia. To see your overall score, you click on the overall score here on the top tab. and then under calculation. Under calculation, you have all the information you need. So this is how much you completed so far based on how many points. So total in this semester you have to do 410 points in the homework, 290 points on quiz, total 700. So far we have 270 and 178. So you get these numbers from my math lab and you place them in the calculator. I forgot the number, 270, 178. So homework 270, you put them here, 270 and quiz 178. You put the quiz date, not quiz date, sorry, quiz points under the quiz. And for attendance, if you know how many days you are present, you put them. If you don't know, you can ask me. So let's say we had 15 days. Let's say she was present in all 15 days. And then you know your home exam 1, 2, and 3 score. If you don't know, you can find them on Brightspace. Let's say we have 100, 100, 100. And then you can guess your exam 4 and 5 score. Let's say she also got 100 here, 100 there, and then she got overconfident. She didn't study for the final exam. Okay, suppose. So let's say she barely passed the final exam is 50. Then if she doesn't improve any homework score or anything, the score will be 77. 77 is a C plus. But let's say you want to improve the exam score, so homework score. So if you get all 410 in the homework, okay, it turns into 81, and 81 is B plus. But obviously she is not looking for 81, she's looking for A. So let's say in 290, she got 250. Now she has 83. 83 is B. So maybe she can improve more, 270. Still 83. So that means, let's see what happens when you are present for 35 days, in 36 days. See, it went up to 84, but from 83 to 87, all are B. That means it doesn't matter how well you do in class exam, homework, and quizzes, you definitely need more point than 50. So let's say she has 60, not enough for her A, 70, not enough. But with a 70 in the final exam, she has A minus in this class. But she's looking for A, obviously. So let's say 75, not enough. 77, still not enough, but close. 79, maybe she can have 78. Nope. She needs exactly 79 in the final exam to get 93 or above, which is A. So see, you can play around with this calculator, with these numbers, and see how much you need to have in everything except exam 1, 2, and 3 in order to get what grades you want, what grade you want in your overall class score. So I posted this calculator on Brightspace. Play with that and see where you're standing. Any question? Okay, so now I told you how to use this calculator. Now let me remind you, our next exam is next week, Friday, on 11th. Once you take your exam, you have 1 full week of for vacation. So you can relax for a week. But then when you come back, we have another exam on May something, I forgot. I also posted the review sheet for our next exam on Brightspace. If you haven't seen it, you can go and see that. The review sheet is based on 7.4 to 10 point something, 10.3 or something. But let's see how much you can finish by next Tuesday, and then we will decide our exam will be based on what. Question? Comments? Anything? Department makes the final. But I'm already giving you all the questions you'll see in the final. So if you collect all those questions, when I say this will be in the final, if you collect all those questions together, you have the final exam before the finals. Even though I don't make them, but I seen it in previous semesters, they always have similar questions. No surprises. So in our last class, we were done with chapter 7, and I forgot that we have one question to discuss in section 8.4. So let me open that up. We did chapter 7 and from 8.4, section 8.4. In 8.4, we discussed variation. And we said we have two types of variation, direct and inverse. Direct variation means when two things are changing in the same direction. For example, when you, the more you work, the more money you make. So the two things, number of hours and the amount of money you're getting, they both are increasing, so they have direct variation. Inverse variation means when one is increasing, other is decreasing. For example, the faster you drive, the less time it takes you to cross a distance. So you're driving faster, but you're taking less time. One is increasing, one is decreasing. So they have inverse variation. For direct, we write in a straight line, y equals kx, and for inverse, it's y equals k divided by x. So inverse means the two things they are changing. One of them has to be on the numerator on the one side of the equal sign. The other one has to be on the denominator on the other side of the equal sign. When you're direct variation, the two things you're changing, they're on the same level, same numerator. They're changing by a constant k. And we did few examples. Now, this is one of the final exam questions where you don't need any math. You just need logic to figure this out. It says, suppose y varies inversely with x and directly with z. Then, if you want your y to increase, which of these two scenarios must be true? So let's start with the equation. What is our equation? First thing we look at is what is changing. Which two things are changing? So here actually three things are changing. Y, x, and z, right? Now how y and x are changing? Inversely. So y equals what? K over x. K means the rate at which they are changing. Now with the same rate, z is also changing. But how z is changing this time? Directly. So where does z go? On the numerator or on the denominator? Next to the k on the numerator. So when three things are changing at the same time, we call them joint variation because they are changing jointly. So this is our equation for this variation. And they want definitely y to go up. We want to increase our y. So if you definitely want your y to be going up, then how x and z must change? Let's see them individually. If you want, so we have y equals kz. If you want y to go up, that means z has to go up or down. Which one? Definitely up. Because when you multiply something with a number, if you increase this number, and that number will increase. So if you want to increase your y, your z must also increase. And then we have the second scenario here over x. Now, if you want to y to increase, what do you have to do with the x? Do you want to increase the x or do you want to decrease the x? We want to decrease the x. Why? Because the smaller the denominator is, the bigger the number is. That's the reality. If your denominator is smaller, that means you have a big number. But if your denominator is bigger, that means you have a small number. So when denominator becomes smaller, the quantity becomes bigger. So if you want your y to be bigger, you want this quantity to be bigger. So that's why in order to have this quantity bigger, we want the denominator to be smaller. So which of these is true? X increase, z decrease, or x decrease, z increase? We want x to go down and z to go up if you want your y to go up. But if that's for the reverse scenario, if you want your y to go down, then the scenario will be, the answer will be A. So see, you don't need any math here. You just observe and use logic. If you don't know how to use logic, plug some numbers and see which one makes sense. For example, let's say here z is 1, 2, and 3. See what happens. Y is 1K, Y is 2K, Y is 3K. Which one is bigger? 1K, 2K, or 3K? 3K. So see, if you want Y to go up, your Z must go up. And for the other one, we have, let's say X is 1, 2, and 3. And let's say your K is 1. So your Y is 1 over 1, 1 over 2, and Y over 1 over 3. Now, which one is bigger? 1 over 1, 1 over 2, or 1 over 3? 1 over 1, which is a whole number 1. So if you want your y to increase, your x must be small. So you're decreasing your small. You're decreasing your x. 1 is bigger than 1/2. 1/2 is bigger than 1/3. So see, the bigger the x is becoming, the smaller the quantity is getting. That's why you want x to be small, but the z to be big. So 2 ways of doing it. Use logic, or you plug some number for your scenario and see what happens. Clear? Any question? So with this, we are done with section 8.4. And now we are going to chapter 10. In chapter 10, we are going to talk about radical. How do we simplify radical, add radical, multiply radical, add, subtract, multiply, divide, simplify, evaluate, all these things. How do you solve radical? So I think I told you before, but I'm reminding you again. Radical has two things. One is the index, and one is whatever we have inside the radical. So whatever we have inside the radical sign, we call them either index, root, or radical. There are three names. So if you don't see any number, we call them square root. So index is 2. If you have 3 inside the radical, like if you have this, we call them cube root. It means your index is 3. If you have 4, we call them fourth root. It means your index is 4. So whatever number we have inside the little tiny radical sign, its name is index or root. And whatever we have inside, its name is radicand. radicand. It could be a number, it could be an expression, it could be a variable, it could be anything. Whatever you have inside, their name is radicand. Principal and negative square root. If a is a non-negative number, then square root of a is a principal or non-negative square root of a, negative square root of a. So the little tiny box is saying that depending on your position of the negative, you get different results. For example, if we have a negative in the radicand, that means you have a negative radicand, but your root is an even root, like square root. For example, square root of -1. What is square root of -1? It doesn't exist in the real world. So anytime your radicand is negative, but you have an even root, the answer is DNA for now. But later in this chapter, we are going to learn about imaginary numbers. So that time, square root of a negative number will not be DNA anymore. It will be something related with I, means imaginary number. And if you have your negative in front of your radical, so your radicand is a positive number, and you have a negative in the front, it means negative times your radical. So the answer is negative of square root of the radical. For example, here, we have a negative times square root of 1. So we write negative, and then what is square root of 1? 1. So it's negative times square root of 1, which is same as -1. So if a negative sign in the front, it doesn't affect us. But if you have a negative sign inside the radical, in the radicand, then you have a problem for even roots. The next one is saying, if you have a negative number squared inside, in the radicand, and you have a square root, so even root with the same even power, it doesn't matter what do you have on the radicand, it could be positive, it could be negative. The answer is always the positive of that number. But remember, the power has to be inside the radical. If we have power outside the radical, then it's not true. For example, -1 square is not 1. Okay? But -1 square and then square root, the answer is 1. So the position of your square, position of the power does matter. If the power is inside, you get a real number. But if your power is outside, it's not a real number. Why? Because whatever comes inside, you always have to do that first. So for this one, we have square root square, -1 times -1, +1. And what is square root of +1? 1. That's why if you have a square root of -1 square, the answer is 1. But in the other case, we have -1 and then the square. So we have to always start with the inside. What is -1 under the square root? It doesn't exist for now. But later we are going to learn that this thing is I. So we have an I with a square, and I with a square is actually -1. You see, they look same, but because of the position of their power, they have two different answers. Now let's do some examples. Start with very easy example. What is square root of 0? 0. What is square root of 36? 6. Then we have a negative. Is it inside the radical or outside the radical? So is it a multiplication or it's a not real number? So multiplication is outside. So you bring it down and the numerator and denominator. Outside means multiplication, so you bring it down. What is square root of 16? And square root of 81? 9. Who would like to do D? Mohammed, go ahead. Negative 11. Square root of 121 is 11 because 11 times 11 is 121. And square root means what number when you multiply twice the same number turns into 121. So you have a negative outside. So it's a multiplication. We bring it down and we find square root of 121 is 0. How about E? The negative you have, is it inside or outside the radical? Good. For now, okay? But later, when you're going to learn about imaginary number, it will not be DNA anymore. Who would like to do F? We have square root of negative 11 square. Positive 11, right? It is positive 11 because first you have to apply the power. So before giving you the answer, actually, let me do one more step. So you have square root of negative 11 square means negative 11 times negative 11 turns into positive 121. And square root of 121 is the positive 11. Would like to do G? Jeremiah. Wonderful. Negative 11. So the first negative is outside the radical, means multiplication. And then, as we did the last question, we have to start with the inside. The inside is telling us to square the negative 11. So we get positive 121. Multiplication means bring it down. Square root of 121, we already did that in F. It's 11. So they look same, but just because you have a negative in the front, this becomes negative 11. Any question? Now we're evaluating radicals. Just like we evaluate any other function, all you have to do is replace x with whatever number they give you, and then simplify. So we have f of x as square root of 3x plus 5. They want us to find out what would be the y value when our x is 2. So you replace every x you see with 2. We have 1x here, 1x there. So every x turns into 2, and then you simplify. How do you simplify the inside? Do you do 3 times 2 first or 2 plus 5 first? Which one? 3 times 2. What is 3 times 2? And what is 6 plus 5? Do we know what is square root of 11? So you stop. You try one. Ready? Danielle, what did you do? Ronaldo, what did you do? We are finding f of negative 18. Same sign, do you add or do you subtract? Add. So 107 plus 18. 7 plus 8 is 15. 1 goes on the top as an addition. 1 plus 1 is 2, and then we have 1. Can you think of a number when you multiply 3 times, it turns into negative 125? Only 5? 5 times 5 times 5 is positive 125. But what do you have? So we rewrite this as negative 5 cube. The cube root, cube power cancel out. What's the answer? Negative 5. For odd root, whatever we have in the base, after you cancel the power, that comes down. But for even root, it doesn't happen. For even root, first you have to distribute the power, and then you take the root, square root. Any question? Okay, now you're going to simplify the radical. Square root of x squared. Do you have the same radical and power? We do, so you can simply cancel them. The answer is only x. For the next one, we rewrite. Remember the rule? This one. If you have the power and radical at the same time, power goes on the top, radical goes on the bottom. So our power is 12. And what is square root? Square root means which number? 2. So 2 goes on the bottom. Can we divide 12 by 2 evenly? How much you get? 6. So answer is x to the 6. Basically, we are looking at how many x squared we have in x to the 12. This is what it means. How many x squared we have? It's x squared because our radical is squared. So how many square we have in x to the 12? We have 6 of them. So x squared, x squared, x squared, x squared, x squared, x squared. We have 6 of them. The answer is 6. The next one has both numbers and variable. So when you have this, we split them into 2 pieces. One is for the number and one is for the variable. So cube root of negative 64 and cube root of x to the 9. Can you think of a number when you multiply it 3 times, it turns into negative 64? Negative 4. So we rewrite negative 64 as negative 4 cube. Cube root, cube power cancel out. From the number, we get negative 4. This one is asking how many x cube you have in x to the 9. This is what it means. How many x cube, because we have a cube root, so how many x cube we have in x to the 9. We can easily figure this out by rewriting in a division sign. So 3 goes to 9 how many times? 3. So we have negative 4 from the number, x cube from the variable, then we put them together as one whole thing. Any questions so far? So see, all these examples we did, the power was divisible by the radical, or it was a perfect root number, like 64 is 4 cube, 96 is 94 cube, and previously we did other number 125. But not always it will be the case. Sometimes you will have something that is not a perfect number. So what do you do when you don't have perfect numbers? Step 1 is same. We rewrite using two radical. Oops. Since it's not perfect number, so we look for a perfect number inside whatever we are given. For 81, we are looking for same number 3 times. So let's split 81 into prime factorization. When you see 81, what 2 numbers comes in your mind? 9. But both of them are more divisible, right? So you divide them more. 9 is what? 3 and 3. That means if you multiply 3 4 times, it will turn into 81. But we are looking for same number how many times? 3 times, because we have cube root. So we group 3 of the same number in one group, and whatever is single, we single it out. So we rewrite cube root twice. Inside one radical, we put the group of 3. Then how many 3's left? Alone, 1. We put it inside another root. We group them into, we take 3 into one group because our goal is to cancel the 3 root with the 3 power. That's our goal. So 3 root, 3 power cancel out. We get one whole number 3, and the single 3 inside the radical is single. We can't do anything, so we put it next to the whole number 3. That's how we simplify numbers. If it's not a perfect number, no problem. Break it down to see, do we have a perfect number? Similar case. We have cube root and cube root. Now, what is the smallest power of 14 that is divisible by 3? What is the largest, smallest number of 14 that is divisible by 3? For example, is 14 divisible by 3? Is 13 divisible by 3? Is 12 divisible by 3? So smallest, biggest number is 12. And then how many we have left after we use 12? 2. So 2 go inside one of them because this is not divisible by 3, but this is divisible by 3. So this becomes x to the 12 over 3. 3 goes to 12 how many times? 4, right? So we get x to the 4 here without radical, but this one is smaller than 3, so we bring it down. Now, if you observe, there's something extra outside, something extra outside. We have some single thing inside, some single thing inside. So instead of putting them into 2 different walls, we put them together as one. We said, hey, 3 and x to the 4, be friends and hang out with one another. And then inside the radical, we had 3 and x squared. So we put them together inside one radical. And now it's the final answer. We separately solve each one of them. We simplify one, not solve. We separately simplify each one of them. And then at the end, whatever is outside the radical, we put them together in the outside. Whatever is inside the radical, we put them together inside one radical. Who is lost? Tell me, why do you need one qualification? The number? Yeah. So we have 81, but they're telling us find one number 3 times inside 81. We don't see them, right? So we split 81 into the 2 numbers you always see. We see 2 9s inside 81, right? 9 times 9. But we're looking for same number 3 times, not twice. So we split them more. 9 is 3 times 3, another 9 is 3 times 3. And now we cannot split them anymore because these are 5 numbers. Now once you reach your 5 numbers, now you observe and see, do you see the same number 3 times? We see 1, 2, 3, 3 times. We need same number 3 times because we're dealing with cube roots. If you're dealing with fourth root, you look for same number 4 times. If you're dealing with square root, you'll look for same number twice. So depending on what is your index, you look for the same number that many times. So we need same number 3 times. We found it 3 times. And then we have something that is not inside the group. So we put them together extra. Now why do you care about 3? Because we have a cube root. Our goal is to cancel the cube root with the cube power. So in root and power cancel out, we get our radical 3 alone without any roots. And this is nothing to do, so we bring it down. Are you okay with the variable part? See, when you simplify the numbers, you have 3 extra, and then you have 3 inside. When you simplify the variable, you have x to the 4 extra and x squared inside. Now these 3 and this x to the 4, they are not inside radical, they're free. So you put them together and tell them, hey, go roam around anywhere you want to go. So they become friends. And this 3 is sad, this X4 is sad because they're inside the radical. So you put them together, at least they can play with one another. Any other question? Mustafa. We're going to do more. For example, this. 7th root of x to the 14. So you can rewrite 14 over 7. Can you divide 14 over 7? Can you divide 14 by 7? 2. If you can divide, that means you are done. Your answer is that. But if you cannot divide, like the next one, if you do 10 over 7, can you divide 10 into 7 equal pieces? So 7 goes to 10 how many times? Only once. And how many remainder we have? 3 of them. So you have 7th root of x to the 7 and 7th root of x cubed. You split it, you 10 x's into 2 pieces. In one group, x with 7, and one group with a 3. Now, why do you do? Because as long as you have the root and power the same number, you can cancel them. So you get your x alone, but the other one, we can't do anything. So we bring it down next to the single one. The next one, we have 2 radical, but the same radical. And we have a multiplication sign between them. That means it's time to multiply radicals. We can multiply radicals if we have only one condition satisfied. That condition is as long as they have the same index, you can multiply them. That's the condition. If you have different index, it cannot multiply them. But as long as you have same index, everything is multiplicable. So what we do, we write a big, not a big one, 2. We write 2 big radical. We put the numbers together as a multiplication. We put the variables together as a multiplication. So we have 9 times 9, x to the 5 times x to the 9. So you multiply the numbers, you multiply the variables, and since they are different from one another, so we use 2 different houses for them. One house is for the numbers, and one house is for the radical. Sorry, variables. Now all you have to do is simplify them. Cube root means you're looking for same number 3 times. Do we see same number 3 times? That means you have to break them down. So you break down both of them. 9 is what times what? So we break down 3 and 3. Now do you see same number at least 3 times? Which number? 3. So you put 3 of them together, and then how many single we left with? 1. So cube root of 3 of them and cube root of a single one. What happens to the cube root and cube power? Cancel out. So what remains from the first radical? Only 3. The second one is sad. We can't get it out. So we just bring it down. Now comes the exponent roots. In multiplication, what do you do with the powers? Add them. So for the variable, we get x to the 5 plus 9, which is 14. Can you divide 14 by 3 evenly? That means you have to split them into 2 pieces. How many of them we put together? 12. Because you can divide 12 by 3. That means how many of them is extra? 2 of them. 12 divided by 3, how many we get? 4. So from here, we get 4 of them free. And this is sad because we can't simplify them. So we just bring it down. And now we look at them overall. Which 2 things are free? 3 and x to the 4. So we put them next to one another. Actually, let me write in the middle so you can see. 3x to the 4, these are free. They're adults. They don't live with their parents anymore. But which 2 things are not adult yet? 3x squared. So they live inside the house with their parents. And what is their parents? The cube root. And guess what? These are finalizing questions. In the final exam, you need to do multiplication. So try more. And for some reason, they actually love cube roots. Most of the time, they give cube root, most of the time. But we are going to practice with everything. Cube root, fourth root, square root. We have one more. Yeah, I have one more. Let me write it here. Cube root of 3x to the 7 times cube root of 18 x to the 9. Okay, try these 2 questions. Oh, I forgot to take attendance. So, let me take attendance now. Today is 4-3. You don't have to work alone. You can talk to your neighbors. Eliza here, Fabricio here, Sergio here, Miley here, Oliver here, Himadri here, Mustafa here, Jacqueline here, Jiain here, Anaya here, Adsiri here, Joseph, Sitlali, Saida here, Mohammed here, Ronaldo here, Danielle here, Jeremiah here, Camila here. I did perfect attendance today. People who did not drop. Thank you for being here, guys. Who needs help? Great. The next one. Accept when we take real time to realize and a single one says single is the house. So you have 2 people here. One of them is this, and one of them is for the two. Just like this one. You see, you want to feel them, what you think that is. So it goes inside one of the pieces. And then CPI, this is the goes, yes, yeah, so take it to the right. Before you even break, just you don't together. Yeah, extra 5 is and then you do. Great. It was like I think so. What is this? Which number is what happening? Happening in the vision, right? That means actually one of them. And how many is that? Why do you have one? It's one times two, right? So it's one times two. Two. If that one square, it's one times two. So it's power that is bigger than this one. That change. Oh, this is easy. Actually, we can two uses. One is pure power, one is one power. So pure and one power. Oh, so small number that is easier by the so you know, packing your kilos, then you chill to your back. More cheaper, more reasonable. With something that you can do more. So that ratio is in number two times. So it's 50 times, so that's 50 times. That is 16. Yeah, 700. This is actually, yeah. Let me also give you a reflection. I always forget to give you a reflection. And this exam has reflection 2 points. So fill out the reflection before you go, and you get 1 point in whatever you have in your exam. Reflection for exam. And if you don't want to fill out now, you can take it home and bring it tomorrow. Yeah. So if you want to fill out at home, you can take you home, bring tomorrow. But if you want to fill out now, you can fill out now also. So you got them. What happened? That's why I did not multiply. If you notice, I told you not multiply. See, I didn't multiply, notice that. What I did instead, I wrote them down. So don't multiply into the beginning, because we're gonna make it three. Instead, put them, put them. What is 25? Up to numbers. What means 10? Up to numbers. What are you? Wow. That's why don't multiply and making like hundreds. Instead, split them at the beginning. So let's do them. We have cube roots of the numbers 25 times 10. Let me use this. And we have cube root of x to the 5, x to the 8. Now don't multiply 25 and 10. Instead, break them down, because our goal is to see something 3 times. So if you multiply them, it doesn't help you. 25 is what two numbers? 5, 5. 10 is what two numbers? 3 and 5. Do you see the same number 3 times? Which number? 5. So you group them into one group. Cube root of 5 cube. And then what number is single alone? 2. What happens to the cube root and cube power? Cancel. So what remains? 5, which is free and happy. But this 2 is not happy because it's underage. It cannot leave the house. We go to the variable. Multiplication, what do you do with the powers? Add them. So it is 5 plus 8. Huh? 13. I thought you said 15. I was like, okay, so 13. Is 13 divisible by 3? If it's not, we split them into 2 pieces. What number below 13 is divisible by 3? 12. So we write x to the 12. And then how many power is alone? One of them. Now 12 divided by 3 is what? So we have x to the 4. And again, this x is underage, so it has to stay inside the house. Now there are 2 things. They're adult, they're free to put them together. And there are also 2 things, they're underage, they're sad, so we put them together. And we are done. That's how we do multiplication, multiply, and simplify. One more, the same scenario. Tomorrow we are going to do different power instead of cube root. So we have 3 times 18, and then cube root of x to the 7 times x to the 9. Now, if you multiply 3 and 18, it will be miserable. So don't do that. 3 is 1 times 3, and 18 is 6 and 3. Do you see the same number 3 times? That means you have to break it down more. 3 and 2. Now, do you see the same number 3 times? 1, 2, 3. So you put them together in one group. Cube root of 3 cube. And then inside another group, what goes? 2. Cube root keep power, they fight and die. We get the adult 3. And the underage 2 stay inside the house. Now you go to the variable. X to the 7 times x to the 9. What do you get? 16. Is 16 divisible by 3? No. That means you have to split them into 2 pieces. What numbers below 16 is divisible by 3? 15. So x to the 15, and then how many remains? 1. Now 15 divided by 3, how many? 5. And then we have a sad one inside. So happy and sad, we put them together. Happy goes with happy. So adult meets adult. And we let the underage to play together inside the house. Any of them? Any question from anyone? Remember to bring your reflection tomorrow, guys. Look at your exam, see how did you do, and then fill out your reflection. Reflection is 1 point, and we are doing 10.13. 10.1 is done, so make sure you do the homework on 10.1. And don't forget to go to your PLTL tomorrow before class. Question?
Yeah, I want the information for this.